There everyone, so I wanted to do something a little bit different this week when it comes to the scenarios that we've got to do for Chemistry 101. So I was looking through the scenarios and I've gone through every single one, and I actually have found that there's a couple of them that have been a big struggle for me specifically. So one of the biggest ones that I found a lot of strength in this week was in learning it and better understanding it has been option number 3. So option number 3 says Kyle struggles to understand when to use a Roman numerals in his ionic names. He doesn't understand why you have to include them. Explain why Roman numerals are necessary in ionic names. How can he know when to use Roman numerals and when he doesn't? Use several examples in your explanation. Be sure to cover how to start with a chemical formula and name it, and how to start with a name and come up with a chemical formula. So I wanted to dive into specifically what an ionic what the ionic names were, or what ionic compounds are, more specifically. So ionic compounds have to do with if we're looking at the periodic table, looking at our metals right there in the middle, and then non-metals over onto the right side. And the next step, knowing that, if we realize that our metals will always have a positive charge, it'll have a positive charge, and then in an ionic compound or bond, it'll either be with the nonmetals there or a polyatomic ion. Okay, and that's getting a little more in depth to it. An example for Kyle would be something like, say we're going to take iron fluoride, for example. That we're just going to go with that for now. So we have iron, and then we'll say we have iron 3 fluoride, okay? In the name, it would say iron, and then it'd be Roman numeral 111, or III, and then fluoride. Now, the important thing to know about this is that the 3 actually has to do with iron itself. It actually explains what the charge is of iron. So iron 3 chloride would infer that we have a positive 3 iron on it. That being said, if we look over at fluorine on the periodic table, it's actually going to be in group number 7. Group number 7 has a -1 charge, so fluorine will have -1. If we take that -1 and we understand that we have it bonded to iron, in order to balance out that equation, iron has to have 3 in order to properly fill up that charge and to bond with iron. So in looking at iron 3 chloride, or excuse me, fluoride, it would be Fe, and then we'd have F, and then F there would have a 3 subscript, so down below it would say 3. However, in the name it would say iron, and then it would have III, and then fluoride. Okay, a couple other examples. We could go with zinc, or actually let's do iron still again. Iron oxide. Another name for that is actually going to be rust. That's a common name for it. But if we're looking at iron oxide, and then we have a Roman numeral in there. Say we have iron 2. We'll say 2 oxide. I think that would be a good example here. Looking at that, we know that oxygen, being in the group that it's in number 6, would actually have a -2. Well, knowing by what we talked about earlier with iron Roman numeral 2, that would mean that we could look back at the element after that, or even the polyatomic ion, and know that that charge is going to equal, or at least balance out with how many they have. So because oxygen only has a -2 charge and iron 2 has a +2 charge, that would actually explain to us that the chemical formula would be FeO, and then just that's it. So FeO, O has a -2, and then knowing that the name of it is iron 2, we would know that it's balanced out because of the negative oxygen and the positive metal of iron. There's many more examples we could go over. Say we had, let's see here. Here's a good one. So we could do like cobalt and, let's see, I'm kind of making up these as I go. Let's do zinc. Let's do copper chloride. Okay, I don't know if this actually exists in real life, but say we had something that was Cu 3, or excuse me, Cu, and then we had, let's see here, chlorine, and chlorine was, let's see, let's say chlorine has a subscript of 3. So by knowing this, we have CuCl3. Well, looking at the subscript of chlorine, that tells us that chlorine with a -1 charge has 3 total atoms there, okay? Bringing us to a -3 charge on the chlorine, okay? Or in other words, chloride. Looking back over the copper, in order to keep that balanced, the name of the CuCl3 would actually be copper 3, or III, chloride. So just remember that when you have Roman numerals, to always look at the charge of the other element that it's attached to, or the non-metal it's attached to. If you're looking at the name, that will correspond directly to the metal's charge. That charge, from what I understand, is always going to be positive. And then when you look at the non-metal, or even the polyatomic ion, with the exception of the ammonium, it should always be a negative charge. Well, guys, I hope you liked this video, and I hope that helps with your understanding. If you have any questions, please comment below, and I look forward to reading everybody's group discussions. Thanks. Bye.